Hi, I'm Marc Austin, founder and CEO of Hedgehog. This is the AI Hedge, a podcast where I talk with industry leaders in AI infrastructure about the opportunity and the risk in AI and AI infrastructure in particular. And so my guest today is Jonmichael, who is founder and CEO of FarmGPU. Welcome to the show, JM.
Hey, Marc. Yeah, Marc's my partner in crime here as we did this OCP reference architecture for the Hedgehog and OCP fabrics. That was a lot of fun.
It was
We've
a
been
lot of
talking about.
fun. So, you and I have been on stage a few times now. We've talked a lot about, technical networky things. I kind of want to change it up this time, because, it's just good to have a fresh conversation. And I think you've got a lot of really good market perspective. So we were talking about the Open Compute project. Instead of the reference architecture, I want to talk about the Neocloud working group that I believe you're chairing at Open Compute Project. So let's just start with what the heck is a Neocloud? Like, a lot of people have probably never even heard the term. What's a Neocloud?
Yeah, it's kind of interesting when you looked at like the cloud providers in the past, right? You'd have AWS, Microsoft Azure, you'd have Google Cloud, and those are really big options for hyperscalers. And if you were to ask somebody 5 years ago to say, hey, are this brand new category of cloud providers are going to come up and they're just going to like take half the market from the largest cloud providers in the world, you'd be like, that doesn't sound right.
You wouldn't have said that even a year ago.
There's no way that makes any sense. So if you think about a Neocloud, the term was really initially to describe a cloud provider that is very specifically focused on AI workloads. And now, as we're getting kind of farther down, into the agentic era here, almost all of workloads will be AI workloads in some sense or another. Even simple database applications, they'll maybe do some query to an LLM, or if you think about even just like traditional workloads, which were web hosting and database and caching and stuff, like almost all of those will touch some AI service in some way or another. So if you think about, like, I guess the future of clouds, most workloads will be AI workloads. And the reason why Neoclouds made sense, well, one is that, it sounds kind of crazy, but even the traditional clouds, their data centers weren't set up basically to host, AI and GPU equipment at scale.
Why is that? What's the difference between an AWS data center and an AI data center?
Yeah, I would say that the core difference in an AI data center, are like to serve, and obviously the hyperscalers are doing bigger, giant clusters and stuff now. So, but we're saying it in the beginning where, guys like CoreWeave had a head start on, basically designing data centers that are AI first. I would say the first and foremost is GPUs are, the power designs are much denser than traditional compute. One B200 HGX, say 14 to 16 kilowatt, max. We have a customer doing a training run right now, and they're actually using 11 kilowatt per server in production right now. So that's like measured today. That's one server, right? So if you're talking about the Supermicro reference architecture for an HGX is eight liquid cooled servers per rack. So you're talking about potentially, 100 to 140 kW per rack. This is much higher power racks than traditional DCs, had done.
Yeah, so power distribution is a big thing. Cooling is another big thing.
I would say, so the three distinct factors of an AI data center are high power, liquid cooling. Again, liquid cooling is really needed for that density. So if you're going to, and the density is all about scale up domains in a rack. And so NVIDIA invented this NVL72, which is has NVLink switches that have a scale up domain within a rack. And when your domain is the rack, well, now you have to cool everything in that rack. You're talking about, a GB300 NVL72 rack is like $5 million is like the unit of compute now. And that is like to serve one model. Okay, when you have that much density, 72 GPUs in one rack, the only way to do that is liquid cooling. And so
Hmm.
liquid cooling is not, it's not optional anymore. If you want to do these high powered racks, you also need liquid cooling for the chip power density and the rack power density. And then, of course, the third one is high speed networks, which Mark is
Right.
not. Mark,
Yes.
that's a zero. That's the
Networking.
third.
Wait. No,
Yeah.
that was too.
Well,
That's
yeah.
such
I
an
mean,
easy
most.
cue. Why does the network matter in
Yeah.
this
Yeah.
situation?
And most traditional DCs were like, 100 gig, and so this AI data centers, when they moved to these 800 gig switches and fabrics,
Hmm.
well, one is between that, the AI networks have this, the AI has been distinctly split up into two networks. One is the backend network, or what NVIDIA calls east-west, which is the GPU to GPU communication.
Yep.
And, typically on like a cluster, like a B200 cluster, you'd have 8 Connect X7s to 8 400 gig NICs. That's a lot of network bandwidth between host nodes. This is way more than,
Yeah.
pre-AI.
So
There's
why do you need that? Why does the workload need all that network
Yeah. So
bandwidth?
in a training run, there's a step called all reduce. And if you one of the benchmarks we ran as part of the cluster benchmarks is NVIDIA Nickel, the collective communications library. This
Hmm.
is basically a good way to test where like you basically stress test the entire cluster where it's an all to all communications. All the GPUs have to understand what data is in all the other GPUs at all the time. So
Yep.
these domains, um, where you're talking about these different domains, like a scale up domain is, if one unit of the scale up domain is an HGX server, then all those GPUs can talk to each other via NVLink. NVLink is much faster than even PCIe Gen 6, right? NVLink, we're talking about 1.8 terabytes a second per GPU of
Hmm.
communication,
Yep.
across within the domain. If you go outside the domain, now you still want that to be really fast. You don't want it to be 20 times slower. So, but 400 gigabytes a second versus 1.8 terabytes a second, you're about four to five times slower when you have to go outside the box. But that's still good enough to do these bigger training runs, right? You don't ideally you want all to be super high bandwidth, but it's always just a trade off of complexity and cost. And then, so that's kind of this backend fabrics. Again, NVIDIA calls east west, but this is really how the GPUs talk to each other, and this
Hmm.
is very distinct in AI networks where it's very sensitive to elephant flows and jitter and lots of their NVIDIA has both they have SpectrumX for flow control and all the new stuff going on in Ultra Ethernet and stuff to solve some of these AI very distinct problems for using Ethernet in AI workloads. And the other side of the network is really this the storage and the internet. And again, before it was like, oh, storage networks don't need very much performance. It's just like 25 gig or 50 gig, and it's totally fine. Well,
Hmm.
if you're doing inference workloads now, and it's AI, they're AI workloads, and you're potentially talking about like a KV cache offload,
Hmm.
serving production inference where you're trying to lower the dollar per million token, and you want a high cache hit rate. You're talking about hundreds of gigabytes a second of bandwidth to like a B200 node. Well,
Right.
you can't get that on a low, that's a NIC that is like a 25 gig NIC or something, right? So
Right.
now in production type inference use cases, you actually also need a lot of storage bandwidth, which is not typical of again, not typical of traditional networks, right?
Right. Okay. So we got this AI thing. It creates whole new requirements for AI or for just data center cloud infrastructure, right? New power distribution architecture, new cooling architecture, new network that has to be a lot faster, new storage architecture, um, a new group of market entrants address that need in the market early. You mentioned CoreWeave. They went public last year.
Yeah. Oh yeah,
Like,
we were talking about what defines Neocloud. So yeah,
yeah,
that was
yeah,
I was going somewhere interesting. I mean, I actually think that's kind of disingenuous just to say, oh, they're just Neoclouds. They're not real clouds. They're just like fake clouds. Like
well, they're
I
new
think that's
clouds.
I think it's
They're
not true
new
at all.
entrants. Yeah,
I think serving a lot of these guys like Nebius and CoreWeave, they serve a lot more than just GPU as a service.
sure.
It's not just bare metal or GPU as a service. I think a lot of folks think that all the neoclouds are just the same. They're all commodity. They all serve the same H100s, same B200s,
Hmm.
and bare metal, and it's all the same. And it couldn't be farther than the truth. Most of these neoclouds have either some service that they're specialty in, or like the partner we work with is RunPod. They're very focused on developers. They have 500,000 developers. And they've curated a really nice user experience for developers to spin up a pod really fast within a few seconds and get in with
Yeah.
PyTorch and CUDA.
Well, I think we talk about
Mhm.
the infrastructure requirements for AI, but
Yeah.
AI software development is a fundamentally different thing than
Yeah, there's
writing a web
a lot
app
of
or
people focus on these ML ops and in fine tuning and how to orchestrate different AI workloads across the company.
yeah.
There's lots of various levels of neoclouds, but again, I think it's disingenuous to just say, oh, they're all neoclouds and all they do is the same thing.
Well,
I
it's a
think they're
different
all
way of
very
making software, which then drives different platform requirements and different developer user experience requirements, right?
exactly. And
Yeah.
one of those use cases is, hey, renting a large giant cluster to a frontier lab to go do some training or production scale inference. And I think unless people have been living in a hole, ChatGPT and Claude have gotten pretty good. I'm using
Yeah.
them all day,
Well,
every
the
day
more we
for
use it,
everything
there's
we
more
do.
inference now
Yeah,
too, right? It's not all
lots
just
of
training anymore. There's a lot
yeah,
of people
and
using this stuff.
as inference drives a huge chunk of the compute demand,
Yeah.
most of these guys, I think something, Anthropic said something like, they were being, I would say, like the conservativeness on the compute was like they put like what they thought was like pretty crazy, like, hey, we're gonna have to 10x our compute in a year, as far as their plan. Well, their demand 80x'd. And they weren't like that was like, and this is just the start. So how do you plan for something that's growing that fast and you have to invest, now gigawatts worth of power to keep up with the demand for inference?
Yeah.
So a lot of these guys, as you've probably seen, are doing now major deals with the neoclouds at the, kind of like at the frontier lab level where they're renting giant clusters and tons,
Hmm.
getting high amounts, anything that's like 100 megawatts and above, and trying to scoop all that up because they need it, right? There's no way they're
Hmm.
going to scale to,
Yeah.
yeah. Uh, so yes,
Okay.
neoclouds. Yeah, neocloud again, broad term, just means a cloud provider that's focused on AI workloads.
Yeah.
So
I'll use the cliche. There's a paradigm shift in how we do software that's happening right now. So that's created an opportunity for new market entrants in what previously I think we could call it an oligopoly, right? Three-member cartel,
mhm.
AWS, Azure, Google Cloud, providing the majority of the cloud infrastructure for the majority of SaaS or web apps or mobile apps that preceded this AI era. So we now have what's becoming a more competitive market for cloud infrastructure services. Like how many Neoclouds are out there now?
That's fine. So our friends over at Semi Analysis have this thing called ClusterMAX, where they rate the Neoclouds and they also track them. But I think they're on their main page. I think they're tracking like now it looks like between 50 and 80 or something like that. Now there's
Mhm.
probably more smaller providers that just have like a few a few GPUs or a small cluster or something
Yeah.
like that. But
We
it's
seem to keep talking to people almost every week that are planning to build neo clouds that aren't on
mm,
that list yet. So I think there's actually a lot of new market entrants.
yeah,
Um,
and I think they're back to like our original thing where it's like if you came in there's one camp of people that are like well can't the Azure and AWS just lower their GPU prices and get all these guys out of business, and saying like well, okay, well that
maybe.
clearly you don't know
Yeah, but you don't
that.
understand the market. So
Yeah,
let's
well,
talk about
yeah.
that. If you actually look at the price for a B200, there's a pretty big spread in the market on prices, right?
Well, there's a market price that of like everybody else, and then there's a market price for the hyperscalers. Like I mean, meaning like just on their on demand. Like if you want to rent a B200 from AWS, you're going to get ripped off. You're going to pay 3 times the market price. You
Why?
could get you could
Why do they charge 3x market price?
well, they think that well, I guess their customers are big enterprises that already have some giant AWS account and their credit card's already in there, and they're like, oh, well, it's easier to connect to. I mean, their claim is that they can connect to all these other AWS services, but the whole point of
So they do have service lock in. They
yeah,
have
the
existing
vendor
relationships.
lock in
Yeah.
is one of the things that, by the way, like one of the core thesis of neoclouds is, hey, we have this decentralized compute, and how do we enable it to be decoupled from vendor lock in and be able
Yeah.
to run, you know, I'll tell you some of the stuff that we're working on to enable this, but there's a lot of like encryption and tech that we're developing basically to enable the
Yeah.
ability to run in a decentralized way with, um, and not worry about your data being
Yeah.
stolen. But
So like if I'm a CIO at a Fortune 500 company, I've got an existing relationship with one of the big three
yeah,
hyperscalers. I've got a multi-million dollar, maybe even $1 billion annual spend with them.
Mhm.
And I don't have a whole lot of governance on, which development teams are using which services. So everybody starts experimenting with AI. They start running
Mhm.
GPUs, and yeah, it's 3x the price, and it's going
Yeah,
to take me a
and
little while to figure it out, right?
it's funny. I had a blog post I wrote a long time ago. I have to find it, but like basically, it just summed up of like, if you think about why the cloud exists at all, it's supposed to be this on-demand scaling. So you don't have to put upfront capex. You just pay as you go,
Hmm.
and that offers people not a lot of flexibility to only have to pay for what they use. And it was supposed to be this really cost-effective and lots of scalability.
Well, it
Secure,
definitely is when you're
yeah.
developing or
Oh, for
prototyping
sure. And
or
so there's
operating at
lots of
small scale.
there's lots of things that the cloud does very well. I would say
Yeah,
security, like AWS and Azure take security very seriously. Like
yeah,
and they take data durability extremely seriously. Like when you
yeah.
put data in AWS S3, when they say it's 11 nines durability, they mean that been designed so that there's a higher chance of a meteor hitting the earth and destroying it than there is them losing your data. It's just math. That's probability, statistics.
Huh.
So that stuff is real, and that is one of the values of the big clouds. But that doesn't mean that they're also not just completely ripping everybody off. And they have like lots
Okay,
of
so new entrants are competing on price, and on sort of breaking service lock-in with
Mhm.
the big three incumbents. But even within the Neocloud market, there's a spread on spot prices for on-demand GPU rates, right?
Yeah, I would say. I mean, it's not as much as people think. Like there is like one of the things that's interesting in the market is there's somebody that has the compute, and then maybe they need some help. Maybe they're small and they don't like they just bought some a data center and bought some GPUs, but they don't have a partner. So they
Mhm.
would go out to one of these aggregators or platforms and say, "Okay, could you guys just do the work for me and get these GPUs onto your platform, and then we'll do some revenue share between you." And a lot of the times, they'll offer the data center operators. They'll say, "Okay, we'll offer you." We'll say for instance, we'll offer you 350 an hour for a 2-year contract on that GPU, but we're going to actually sell it to the customer for like 390. They get to pocket money in between. So
Mm.
there's these brokers and aggregators, and now people are selling compute futures. I guess it's not surprising with trillions of
That's just
dollars
a
of AI.
temporary supply and demand phenomenon, or is it sustained?
Yeah, I mean, I think at some point, the middlemen will get deleted, right? At some point, like if you're not adding value in the chain, then you're not going to
Yeah.
be able to take any margin. So either you're finding an end customer, which is a real thing, right? Doing one of the jobs that a lot of these brokers do is like they call it offtake. It's
Mhm.
really just a end user demand of like finding a customer that wants to rent the cluster,
Yeah.
and they pair it with the person that has the cluster.
Yeah.
Um, or, a lot of these companies have like their own front end where people can go rent GPUs, and and then there's like the gold tier, which is some of these providers are actually running inference endpoints, but it's very, very hard and complicated to run a inference endpoint that's profitable. It's very easy to run a unprofitable inference endpoint. You just BLM serve, here's my endpoint. It takes 5 seconds, but to run it profitably with lots of concurrent users and driving down the dollar per million token cost is very, very hard.
So it's hard. There are really big incumbents who have a lot of capital, um, who right now are commanding price premiums. Like, what I guess what's the case for and against Neoclouds surviving 3 to 5 years from now? Like, what does a Neocloud need to do to be a long-term competitive player
Um,
in the cloud infrastructure market?
I presented at the OCP EMEA Summit in Barcelona, a few weeks ago. On we started the I'm co-chairing the OCP Scaling AI Clusters for Neoclouds work group, which is basically all about like how do we bring all the OCP goodness that is going on in all the other work groups and apply them to what the Neoclouds need? What are the
Mm-hmm.
problem, the pain points of Neoclouds for scaling, and how does OCP help solve those? It's kind of funny when I was talking back and forth with Claude, doing some research for my script and in the blog post, and it came up with this. It said, yes, the four gettings problems. Getting facilities. So
Mm-hmm.
basically, I mentioned all the AI ready DCs that have high power, liquid cooling, and high amounts of power capacity. And then getting electrons. Okay, the grid.
Mm-hmm.
How do you secure multiple megawatts? Getting hardware fast enough.
Mm-hmm.
Now, anybody who's in our business knows server prices are going through the roof.
Mm-hmm.
Obviously, Dell and other folks had a really good day today in the market after
Mm-hmm.
earnings. Server prices are going up, margins are going up. Margins are not now just only being consumed by NVIDIA and memory vendors. Now the margins are going to other players in the AI ecosystem. So getting hardware is incredibly challenging. There's long lead times, everything's sold out. All
Mm-hmm.
the supply chain is impossibly hard.
Mm-hmm.
And then that last problem in Neoclouds is getting customers. It's like, okay, so now we have all these things. How do we go actually sell it all the way through to an end user and get customers? So the in those problems that there's getting electrons, I would say the public markets are certainly favoring that as like a guiding principle for how to value Neoclouds.
Mm-hmm.
And so any of these Neoclouds, they could say, oh, they have $100 billion deal with some cloud vendor, right? Or we have
Yeah.
a $50 billion deal with Anthropic. But if that Neocloud can't deliver those GPUs to that customer, well, how can they deliver those? Well, they need power. They need data
Mm-hmm.
centers. Well, if you
Right.
don't have those, you're definitely not. It doesn't matter if you can buy GPUs. There's nowhere to put them.
Right.
So
Right.
that is one way to value a Neocloud, right? And I think the public markets have like dialed that in for CoreWeave of like knowing how much capacity they have under management,
Sure.
and they know what the prices they have to the end customers. They know how many racks are getting delivered by what week. I work with SemiAnalysis on their industry and analyst reports, and they know everything. They know how many GPUs are going to what customers at what date and
Yeah.
at what price they're paying. It's insane.
Right.
So that's one way. But there's a lot of like where we play like right now in the long tail, right? We're targeting smaller data centers, upgrades, developers. There's a ton of revenue to be made on the other side too, just like the rest of the world. And
Yeah.
a lot of people are going to ignore that long tail, but there's tons of opportunities and specific customers and workloads and
Yeah.
revenue opportunities to.
So I think the short answer is where you have a new market where there's a massive amount of demand and that demand is continuing to grow. That creates opportunity for more market entrants, more competition.
Mm-hmm.
Competitive markets are generally better for buyers.
Yeah,
And
and like
there's
back
no
to the
reason why that can't continue to persist. I mean, all markets face a certain amount of consolidation at some point, but like,
yeah. Well,
yeah,
the
more
interesting thing
competition's
about these
healthy.
aggregator type companies, or I guess I would say RunPod is one of our partners. They call themselves an AI platform, but they have like a distributed data center strategy where instead of just having one data center provider, they work with lots of smaller Neoclouds like us, and they run their platform on top of them.
Hmm.
Well, so in one of these business models, now all of a sudden you kind of been this decentralized, disaggregated thing. If you were to back to our analogy versus the hyperscalers, right? If you were to back 5 years ago, you'd say, oh, to run a cloud, oh no, you need like thousands of engineers, you need
Right.
giant sales teams, you need BD, you need all this stuff. Well, now you can run a small profitable Neocloud with just a handful of employees. If you have some folks to run a data center, in our case, we're a small company, and
Especially
we're
if you got that Hedgehog AI network that's
of
fully
course,
automated.
yeah,
I
we
don't
have all,
know. Here's
and we
that.
can. The idea is that we can, not being pedantic, like Marc helped us build our first cluster on the networking, and that was a lot of help. We had never built an 800 gig backend fabric, but
Yeah.
before the first cluster, and so that was our topic of OCP Global Summit last year, is like building this
Yeah.
first cluster and all the things we learned,
Yeah.
along the way. But yeah, again, back, you'd be like crazy to think, oh, you can service like hundreds of millions of dollars of revenue with like 5 employees or 10 employees. But it totally is people are doing it right now. And
Right. So we've talked about semi-analysis a couple of times now. I think it's worth explaining who semi-analysis is. It's worth explaining this ClusterMAX rating system that you've talked about. It's worth explaining the different rating tiers and the criteria that you got to meet to reach those tiers. Can you talk about that a little bit and why any of that matters to you?
Yeah. So this ClusterMAX was an interesting thing that, so semi-analysis is one of the largest analyst firms for AI. I mean, they were used as a source for, like, on the CoreWeave S1 when they went public, now on the on the SpaceX S1 for their public. So they are the industry experts and trusted market analysts for all things AI. And well, some of the products that they serve are like, we're subscribers to their TCO report, which basically is like,
Mhm.
I'm doing a nice plug for Dylan and his team here. So Dylan Patel's the founder, but they have like the TCO report, which is like total cost of ownership for owning a
Yep.
cluster and generating revenue and forecasting cash flows of GPUs. They have a data center model, which is like looking at all the different power
They've got
and
a
data
GPU
centers are going
pricing
out with the UI.
index too, right?
They have accelerator model, so beyond NVIDIA, like all the TPUs
Yep.
and who's shipping how many volume of what units when. Obviously, people that are trading stocks like want this data. They want to know what who has the biggest market share and how much revenue these kind of companies are going
Yep.
to generate. They look at the memory market for HBM, and but yeah, so they came up with this idea of like ClusterMAX, which is like, okay, if you're a customer that's renting an AI, a cluster, like what's the user experience and like what are the metrics that actually matter? And
Mm-hmm.
this turns out to be the same list of like what makes a good Neocloud,
And
because
what's the
this is
list?
like the Bible to all the Neocloud providers. The things that they've identified are actually absolutely 100% the pain points of like managing a big cluster. One of the categories is security. So like I personally did our SOC 2 compliance, so like painfully I know that the process, and so doing stuff like that, and ISO 27001 physical security and standard specs. They have tenant isolation for multi-tenancy. So there's
Hmm.
um,
Yeah, that's a Hedgehog feature. Yeah.
yes, okay, yeah. Back to that cloud thing. When you're comparing a Neocloud security versus a hyperscaler, like, well, yeah, the hyperscaler has been working on security and they have like giant security teams, and so
Mm-hmm.
this is the stuff where I would say probably is the biggest gap. I would say to like a small Neocloud versus like a large hyperscaler. But
Mm-hmm.
not to say that it's not impossible. Like Marc said, like if you have just good engineering and like us, like just discipline. I have a security background for doing. I developed the first self-encrypting drives back at Intel and did lots of work across the industry standards on data at rest security. I think it's a very important. They have a life cycle, which is basically going through this like process of onboarding and spinning up a cluster and provisioning and doing rentals and transitioning for customers. There's um, orchestration. I know like they're big fans of Kubernetes and Slurm on top of Kubernetes for training workloads. I've talked to a lot of folks in the inference market, and they're not all Kubernetes based. A lot of the stuff we do our own KVM VM stack, and I think that's what we prefer for AI workloads. But we also do all of Docker through RunPod. But this is certainly very much focused on the orchestration. Basically um, being able to easily have one click and be able to go deploy a workload across an entire cluster. Storage. This is our favorite category. Obviously, if you talked about, if we had to describe, what's FarmGPU's superpower and what's our, differentiation in the market, we're absolutely, we could say with absolute certainty, we're best in the world of
Well, you
storage.
kind of know
Um,
storage, right? I neglected to
yeah,
give you an opportunity
yeah,
to talk about your background, your bio.
yeah,
So what were
yeah.
you doing before you started FarmGPU?
Yeah, so I used to be the product line manager for all the Intel data center and SSDs, and then obviously that Intel sold off that business unit in 2021. I actually left Intel and went to a blockchain company called Chia, but that was before I started Farm GPU. But those folks at Intel that were part of the NAND business unit are now at a company called Solidigm. Solidigm spun off and they're owned by SK Hynix, was the one that bought them. So we actually run Solidigm's AI lab at Farm GPU. So we have all the latest storage ISVs in the lab. We're doing, brand new research on all the the latest KV cache implementations and AI workloads and training and performance. And so we've got a top secret project that we're well, you'll see. I guess next week is going to be the public blog post. But we built the reference architecture for an exabyte scale S3 cluster, and that was a collaboration between a couple partners. And so there's a bunch of just crazy fun projects we're doing on the storage. So yeah, we are absolutely at the forefront of storage in AI workloads. But
and just a great example of where a Neocloud can differentiate by doing a really good job on something that's really important for an AI workload. Storage being
absolutely, yeah. And storage, I mean, the way that they, some of the storage things that they care about are like, cluster level performance, that you're getting, having a ability to have a persistent volume across block, file, and object in a data center. They like, Weka and DDN because they're NCP partners, but we deploy all the major top ISVs. Vast data is the most popular that we have that's live in our data center. And then, we've got S3 through MinIO, and we've got super high performance parallel file systems with Weka. We've got GPU direct storage with a company called Grade. We've got all kinds of crazy stuff. But yeah, we worked with them on their kind of storage. We worked with them on some of the storage.
So you're killing it on the storage criteria on the ClusterMAX rating. What are some of the other things they evaluate?
So I would say the one of the biggest categories in general, like back to, okay, are all these guys the same? Is it a commodity? Well, it's reliability and monitoring are really, really hard. There is no like out of the box thing that just does all the monitoring reliability for you. So that I would say we've developed a bunch of custom products for FarmGPU. Our roadmap has really been derived of like just solving the problems we had to solve to manage a production data center, which is deploying an observability stack, monitoring and diagnosing GPU failures. We see all kinds of failures. There's NVLink failures, switch failures. There's optics failures. There's GPU XIDs. There's out of memory bandwidth. There's driver crashes, kernel crashes.
So it's interesting. I like this morning. I had a call with the analyst team at Uptime Institute. They've been around for a long time, right? They do an annual survey of data center operators. They've been doing it for probably more than a decade. And so they kind of have like a pretty traditional definition of uptime, right? You're online or you're offline, and it's divide the number of hours. And I've been working on this AI network planning tool to sort of like quantify the impact of reliability on your profitability as a Neocloud. And I'm like, those metrics don't really seem right, because you look at like this meta paper that they wrote on Llama 3, and you look at the incident rate, it's like significantly higher, way higher. And the incidents types are different, right? They're more like almost like
we're feeling
anomalies that impact flop utilization, right?
Yeah, we're feeling those very viscerally. But yeah, the idea of this good put, which is even if you're so if you have a GPU failure during a training run and now your state is all messed up and you have to go back to an old checkpoint. Well, now you have to load the checkpoint from this that they've been saving, and then roll back. And so you might lose a couple minutes or tens of minutes of training. Okay, well, if that happens many, many times a day, now you've actually lost a bunch of real time. They call it good put. The GPUs are working, they're online, they're doing stuff, but they're not. If you had to roll back, you lost a certain amount of time and a certain amount of work that you've already done. This is, by the way, how often and frequently an AI lab will do checkpointing during a training run is very dependent on what the failure rate is. Because if there's more failures, then they want to do checkpoints more often. Well, that's not free. There's more network and network and storage bandwidth that you have to drive to that cluster to do more frequent checkpoints. But you can try to improve the good put. SemiAnalysis now has a cool little TCO calculator that kind of has this idea of good put, which is, okay, if you're renting a cluster, but there's incident rates and you have a certain amount of good put, like how does it actually impact your TCO? Well, if you actually include that in the TCO model, it's kind of very it's very clever way to actually show the value of reliability. Because if you're talking about what is the value of reliability, well, it's a lot more than just the good put and availability and uptime. It's like there's a huge distraction from engineering team when things break. It is the first thing that run pods. We were we would say like we were absolutely the smallest provider on RunPod's secure cloud platform for a long time. Now, we're not the smallest provider anymore, but like we were for a long time. And, meeting those requirements was not easy. Like they had,
Yep.
they've designed those requirements to have redundancy on the network, redundancy at the power and the data center level,
Yep.
redundancy at the switch level
Yeah.
to meet those uptime targets, because it's really disruptive and distracting for
Yeah.
customers when things fail.
Yeah. Okay. So you were showing me
Yeah.
earlier today, I think you call it Haystack. You've done a bunch of
Yeah.
innovation with Grafana to come up with an
Yeah.
observability stack. And
Yeah.
part
I'll
of
do it.
that's network.
So now I'll do some
Can you talk about
shameless.
Haystack and sort of how you're using Hedgehog Open Observability?
I'll just do it. Shameless plug for our Neocloud products here. We have two products that we developed. In this category of reliability monitoring. Well, basically to make our job easier, right? So one of those products is called Haystack. That's what we call our observability platform. And one of the things that we did in Haystack was through like Hedgehog exposes all the switch metrics through their API and their control plane. So we just have all those metrics going to our Prometheus database. And it was really easy for me with AI to make some really beautiful dashboards to basically look at all the switch status in real time, to look at the bandwidth and utilization of all the training runs, looking at switch optic status and link status. If there are failures, we can look at the switch counters and get all the sonic switch level info up to our control plane, up to when you talk about observability. One part is just being like, oh, we have a dashboard so we can observe the status of like the entire fleet in one pane of glass and see what's going on.
Mm-hmm. Mm-hmm.
And then the other is getting alerts when things are down. So
Yeah.
when
Or
a
degrading.
link
I would assume
when
degrading.
a link is down,
Yeah.
the customer's training run stops. We don't
Yeah.
want the customer to report that to us. We want to find it before the customer finds it and fix
Yeah.
it. And so I want to have I have like a 2-hour SLA on our for our premium customers doing training. So where if we detect that a link is down, we've had all kinds of optics quality problems. I won't even get there, but where we have to go detect a link is down, send a technician out to a server, and they have to know exactly what the right optic to pull is, and then swap it or clean the fiber, and then we need to know that that's back up. So, so there's one part of monitoring observability that, again, I mentioned like that. It was really easy for us to go expose those from Hedgehog's side to go pipe those into the rest of our stack. But the rest of the stuff, our other core stack is in Haystack. We have two really unique features that nobody else has. One of them is container profiling. So we kind of we have a LLM do classification and all the containers going in and find out, are they training or fine tuning or inference or image gen or video gen, and we can use that kind of data to optimize tuning on the server based on what kind of workload people are doing. And then the other is one of the things we're going to be open sourcing at OCP is our NVMe predictive failure engine. So obviously we know a lot about NVMe SSDs. I was
sure,
lifetime at Intel and developed the NVMe spec with Intel. But I was also one of the very first reviewer of the OCP NVMe SSD spec. And so the cool thing about the NVMe SSD spec in OCP is it was developed by Meta and Microsoft, were the original authors. Well, they just merged their actual cloud requirements into that document and then open sourced it.
Mm-hmm.
So all of the custom firmware features and
the
SSD
beauty of
vendors,
the Open Compute project. We keep talking about OCP. Not everyone might know what that is.
So we that was some cool stuff we built on Haystack. We built a predictive failure engine for SSDs, and then
and there's like we were talking about scale earlier. AI scales out a lot faster, right? Just consumes a lot of resources. When you start reaching a certain scale, you start having statistically certain failure rates, right?
Mm. Yeah, it's funny. I had one of our agents kind of scan through all of our production incident response tickets that we have. Like when there's a GPU that's down and there's a customer workload on it, we have to, we have a SOC 2 format for our incident response, and I have our SRE now all through agents basically generate that incident response and send it to the customer for what was the actual downtime problem and what was the root cause and what was what we were doing to remedy it. And I had it scan all of our production issues, and our agent kind of put it in categories. And, there was GPUs, there was a lot of it's funny, they were out of the storage ones. There was 10 failures in storage, but none of them were SSD failures. It was all file system or mounting or something hung on some service or, and then there was, optics failures and network failures that we've had where there's actual low level PHY stuff and, dirty, we talked about how hard it is to build 800 gig networks. A single speck of dust can literally destroy an entire link,
Yep.
and it's just an absolute nightmare to to manage at scale. So when you start scaling
Well,
out,
and
like
there's a lot of configuration you got to do
yeah,
too, right? And if you get configuration,
it's funny.
that's
I was just on a
problem.
panel. OCP invited me out to a panel in Orlando to speak at this Fiber Connect thing. I'm not a network guy. I'm just a
Yeah.
just a data center guy. But it was fun. When out there, I met the guy that from OCI he's the lead network architect and reliability engineer for OpenAI Stargate at OCI, $300 billion GPU project, largest cluster ever built. And listening to him talk about, it's like funny, like we're talking about co-package optics and all the next stuff
Yep.
in LPO and all these tricks that the industry is looking at to basically solve these reliability challenges. But there's if you solve a power challenge, you might solve a hot swappability or a serviceability requirement, and there's all these different trade-offs you want to make at scale. But it's funny listening to him be like, "Oh, we have those same problems." There's
Yeah.
dust and fiber, it destroys things, and
Yeah.
but dealing with how do you solve that problem at like a scale of hundreds of thousands to millions of links versus like if it's us and it's like a handful, that's a very different type of scale, right? Where you have to start thinking about problems in a whole different way when you're talking about scale. But
And you talked about, okay, yeah, you can have this massive amount of revenue with a small staff. That I guess implies, and this stuff's super complex. It implies that everything's got to be automated. Yeah.
yeah, I guess that's the second shameless product plug we have, which is we developed for this monitoring and reliability, we developed a product we call Shepherd. Of course, yeah, we're FarmGPU. All of our products are named with farming memes, of course.
Yeah.
That's the only way. But yeah, Shepherd is our autonomous SRE. So basically, SRE is a really important job for a data center in Neocloud. It's a site reliability engineer. So basically monitoring the fleet, and if there's an issue, to be able to triage root
Yep.
cause, send the issue to an engineer, and then communicate that to the customer teams and stuff.
Yeah.
So we've basically what I just described of like if you're going to scale the GPUs under management and these things they're much more complex than traditional CPU nodes. Like we have a bunch of CPU nodes in our fleet, no problems ever, zero problems ever. GPU servers problems all the time, every day. We see all kinds of random
Yeah.
stuff. So it just won't scale. You're not going to be able to scale to hundreds of thousands of GPU servers without automating all this. So
Yeah.
one of the things we're leaning in and leveraging agents to the max is in this category of debug and monitoring and predictive failure. And
okay. So you got Haystack on the observability. It's using Hedgehog Open Observability for the network telemetry and network logs. And then you have Shepherd on the sort of automated SRE, which is presumably doing some remediation of issues that you're finding in Haystack.
And it's reading logs, it's reading system and demessage logs and kernel logs. So it is like it discovered autonomously that one of the links was unplugged on one of these switches. Because it said, oh, there's something where there's one of these interfaces is throwing billions of errors. This is not normal. Like I just the agent was smart enough to just say, oh, this was a switch host name, and this is like this thing is called like phi error count, and it's incrementing. So let's flag that as a bad thing. Like when go.
Yeah. And then presumably, I'm going to guess here. I don't know. I don't know the answer to this question. I might get an embarrassing answer, but we've sort of designed the Hedgehog product where, okay, you get this open observability, and then you get this cloud native API, so that you can remediate faults in sort of full loop automation. Are you using the Hedgehog API to in your remediation with?
Yeah, I would say like a big chunk of our problems have actually been physical problems, and again, this is just that our data center might be a unique. Like this is like our first data center is like also a lab where we do a bunch of research and people in the data center moving stuff around and swapping cables, and even these fiber connections are like absurdly sensitive, right? You bump it and the links go out, but so if a problem can be solved with software, like we want it, and the beautiful thing about these APIs, and I love obviously the Hedgehog is all open source. So we can go have our agents read their documentation and go figure out like, okay, what is the API spec? How do we implement that and use it autonomously? So anything that is agent ready is like going to be in our camp. Like we do not want any I do not want any. We're not looking having any humans code like stuff by hand in an API. Like, but with the network stuff, there is a connection to the physical world, right? Like, if our problems are a physical problem where there's a technician has to go to a server and pull out an optic, like you can't solve that with an API. So we're anywhere that can be remediated without a human in the loop, like we absolutely
Yeah.
are moving towards that.
You're
right?
always going to need remote hands to
Mhm.
remove that faulty optic or whatever the component is and replace it.
Yep.
Okay, so we talked about a lot of things. We mostly talked about operations and the things that that SemiAnalysis rates you on in their ClusterMAX rating, so that you hopefully
Oh yeah.
go
Well, I
from
guess
like
we forgot the
bronze
last
to silver
category.
to
We
gold
forgot the
to
last
platinum.
category.
Oh, what's the last category?
It's networking.
Oh, okay, good. What?
Yeah.
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 What
It
are the
seems like an
network?
important one. It
What do
seems
they
like an
care
important
about, or
one.
what do you care about in the network?
Yeah, I mean, I think actually the biggest change that I think that was interesting that obviously Hedgehog was like, one step ahead
Yeah.
was embracing Ethernet, right? Ethernet is now seems like it is won over InfiniBand. They NVIDIA has put Ethernet in their SpectrumX reference architecture
Yep.
for
Which Hedgehog supports
B300,
now. Yep.
and there was just a brand new spec that OpenAI had written and gotten industry support from NVIDIA and
Yep.
Intel and AMD and others called it's MRC.
Yep.
Was multi-link reliable connection or something like that.
Yep.
Or multipath reliable connection. This was very clever, and it's all taking all the good stuff that will eventually be in, I guess, Ultra Ethernet and like basically techniques that were designed to make networks more resilient to failures and keep
Yep.
going and training when things go down. So yeah, I guess I'll give it to Hedgehog for being ahead of the curve on Ethernet. When we built, but yeah, at the end of the day, what the customer cares about is performance and reliability on the network side. So they're the SemiAnalysis ClusterMAX tests for networking. They want to see the real network bandwidth, which is the nickel all reduced, which is how fast do the Rocky V2 RDMA networks work in real life, in real GPU workloads, not just a quick benchmark. So.
Yep. Okay, so operations super important, customer experience super important. Running a Neocloud business, I want to back up to that for a minute, because to get into this business, you've got to find a way to finance buying a bunch of GPUs, which are super expensive. And then you've kind of got this lag time from the time that you've like bought the GPUs to getting them to where they're online and billable. Tell me about time to GPU value and the bullets that a typical Neocloud operator is going to sweat while they're watching the clock tick.
Okay, if you think about the order of operations, one example would be like, because the demand is so high, customers are willing to sign a long-term agreement, like for 18 or 24 months, and then potentially pay up front for a cluster that will be delivered in 60 days. And they are not going to do that with a provider that's not reputable, right? There's 0% chance that they're going to do that with just a random provider. But in that model, then I have to go take that money and then put it down on a down payment for GPU servers. We have to go also spend our own money to go build out colo space, whether it's in a megawatt cluster, you'd have to go, if it's air cooled, you have to go, get higher power PDUs in there and build a cage and build the air cool system, in the or if it's a liquid cooled, it's like getting the chillers and the loops and the CDUs all hooked up. Well, that takes real money. Like before you even start day one of putting the GPUs in, like for a megawatt cluster, we might have already, a couple megawatt cluster, we might have already spent $1 million the day before we even start. And so now when you get to that point, like OpEx is, we'll say on a typical GPU cluster, OpEx may be 10 to 20% of the total revenue per month. If you have a GPU cluster that you've installed, but it's not generating revenue, that's going to be a huge problem because you have to pay the colo a bunch of money to get in there. And then as soon as you put the equipment in, you're already paying the colo. One of the biggest misconceptions is that power electricity cost is one of the biggest drivers of TCO. Well, the dominating part of TCO in OpEx is actually the data center shell lease. And there's no free lunch. You have to build an AI ready data center, you have to buy transformers, there's cooling units, there's like all the infrastructure, PDUs, all the infrastructure required to build out a data center. Well, it doesn't matter if you're in Texas or Colorado or California. The equipment is the same equipment. But so if you're paying that shell lease, and right now the going rate for colo is like, we'll say $150 per kilowatt per month. So on a megawatt, this might cost me, before I even charge for power, just to lease the building and reserve that power for me as a customer, I'm paying $150,000 a month. So if you're 3 months late to a cluster, now you've missed on a megawatt cluster, I've missed $1.4 million a month times three. And then I've also lost, $450,000 on OpEx plus all the money I put up front. So if you're 3 months late
Well,
to a cluster,
and it's a rapidly depreciating asset, and there's interest expense on it.
yeah,
And
well,
it's also a high value asset. So every day you're not renting that GPU is a day of lost revenue too, right?
yeah, and it's this time to market, time to revenue for GPUs is a very important metric for us of like how fast can we, when we get a GPU shipment, so it's coordinating the data center build with the equipment rack and stack. It's coordinating with having the network ready before we install the GPUs, so that when we install the GPUs, we just can plug in the optics and then test all the links and get everything ready to go. So I mean, and it's hard because in a perfect world, all those things are on different cadences for delivery. So timing the data center with the equipment shipping at the right date, and you don't know if things get back ordered or I mentioned like lead times are just through the roof right now. So it's really, really hard.
You're like a general contractor who's managing a construction project with power and cooling, and a technical program manager managing an IT project, installing compute, storage, and networking. And you're in a supply constrained environment where there's long lead times on a lot of components and sort of availability risk. It's a lot to pull off.
Mhm. Definitely. And we're, I would say there's not like a secret sauce to that besides being like good operations is like incredibly challenging, and you need good people that understand the supply chain and sourcing and timing and working with colo providers. And
So given all of that supply chain risk, what's the value, I guess, of open source and open specification computing? Does it help you hedge some of that risk?
yeah, I think a big chunk of I mean, obviously, like, so for folks that may not know, FarmGPU was customer number one for this new OCP collaboration for the open reference architecture for training and inference that
Yeah, you
was
contributed
put,
a lot of
put
your
together.
infrastructure's code. Yeah,
Yeah.
thank you for that.
Yeah. And Hedgehog, I have to thank Hedgehog and Celestica for, doing a bunch of obviously the heavy lifting, but the idea was that we want some reference validated solution that has, that's been documented obviously open source is a way to have other people verify and contribute to the work, but having it seen as a real viable solution now, so especially that helps with showing customers like, no, it isn't just some random thing we built. No, it's like
Mhm.
a OCP reference architecture that we are so it's a known good thing. And now that we have built it once, we're going to use that for all of our other clusters because we know it works and the TCO is good. So, yeah, the fact that it's
And
open
it
source.
also, that openness, it should help you. Like, are you looking at disaggregated inference? Are you looking at putting not just NVIDIA, B200s or B300s into your data centers? Are you looking at sort of
Yeah, I mean,
multi-vendor
and
XPU?
on the inference side, I would say, we're open to anything, any XPU that generates revenue is good for us. Neocloud,
Yeah.
whatever it is. I think the next big challenge we're working on is these storage ones I mentioned. For
Yep.
now that people are not just running inference like for testing, that are running in production, they need KV cache offload and high amounts of storage that is super high bandwidth
Yep.
delivered right to the GPUs, and so that's one of the things we're working on. But yeah, it's exciting. Obviously, we are big contributors to OCP. I worked very closely with OCP on the storage spec for many years, doing EDSFF SSDs and the OCP NVMe SSD
Yep.
spec. And I was a contributor to the sustainability project, and I wrote a couple white papers on
Yeah. So it was
sustainability.
sort of
And
a natural for you to get involved in this Neocloud working group.
yes,
I'd say probably a lot of Neocloud founders or operators, well, they don't have the same background as you in most cases. So how do they get involved in this OCP work group? And what's the benefit to them if they do?
My favorite thing about OCP is that when they say open, it really is open. Every single meeting is recorded and posted on YouTube. All the meeting notes are available in a shared Google Doc. Everything gets posted. All the specs, when somebody contributes a spec, all the reference code and source has to be all open source and available. And so I just, that is the spirit of openness. You know, obviously open source is beneficial because, if you're going to, if it's something is going to be better by other people contributing and collaborating to it. So imagine like you're in Hedgehog's case. I mean, Marc probably speaking for you here, but like I imagine the reason why they like open source is customers know what, like they know they can inspect the code and know that there's nothing bad there. There's
Yeah.
other people that can contribute to the code base if they want custom features. There's no vendor lock-in. And so they don't feel like, hey, if Hedgehog just decides to walk away right now, our giant switches and our entire AI infra is not just going to become a brick. Well, that's really important. Like for a customer like me, I'm like having no vendor lock-in. I don't want to, like, if I stop paying my support contract for my router, are they going to like delete all the features? That wouldn't be very cool. Like I would, and just
Yeah.
brick all my stuff. So open source is like extremely, and there's lots of ways to make money in providing open source software by being the guy to help install and
Yeah.
tune and write custom features for customers. So.
Yeah. Great. All right. Well, we're over an hour.
Oh man, we are toast. Yeah, people are going to be like, "What are these guys talking about?"
You and
It's
I could
Friday.
keep talking forever.
It is
Uh,
happy hour time here in California.
yeah, it is Friday. So, all right. Well, Jam, thank you so much. I love talking to you every time. And I'm super happy to have met you, to have partnered with you on this journey. And, just really looking forward to your hyperscale, path going forward, which for sure is happening.
Likewise,
So
sir. It's been a big fun ride here.
great. All right, man. Well, take care. We'll see you
Yeah.
soon.
Thanks a lot, Marc.
Yep. Bye bye.